Okay, welcome to the penultimate week of our course. Sorry, the camera's shaking around. It's week 11, so we have this week and next week is all. So a couple of things about the schedule. There'd been a request to move the final forward and to move the project back. And I thought about that for a while and looked at the pros and cons, and I think it's going to be better for all involved to leave things as they are. I don't want to cut the time short for people studying. So again, I'm going to do away with the option of the 1 3-hour exam and have 3 1-hour questions for the final. If you want to take it all together, then you can certainly take it all together, take it sequentially, that's fine. But hopefully that'll give you the flexibility that you need. I understand classes may be starting, that's a real mess, but I can't really push things forward for the final. The final really needs to be at the end of the class, okay? So then to review the final exam will be available Wednesday, Thursday, and Friday. Okay, so it should start Wednesday morning by 10 at the latest and be available through Friday at midnight. Again, Friday's the last day of the class, has to be done by then, okay? So as far as next week, just while we're at it, there will be an office hour Zoom on Tuesday at 7, which is the night before the exam goes live. So that'll be our review session. You can have any questions that you have. I've already, for last week's video office hours on Thursday, did a brief overview review session of what's going to be on the exam and what's not. Okay, I didn't cover chapter 14, which is this week, but I'll cover that in the video, and then there'll be some more opportunities to ask questions on that as well. Okay, so all homework, again, if you've turned any homework in late, some of you had some issues in that it wouldn't allow more than 20. I can't make it allow more than 20 files. So for some of them, you had more classes than that. In that case, you don't have to upload the class files, just upload the Java files. I think that got most people under the bar. If not, you could always zip your files together. If you're not sure how to do that, I think you just select them and right click in the Mac, but it may be different in Windows. But you can look that up or ask someone for help in the class on the forum for the week, and you should be able to figure that out. Okay. Yeah. So all the homework then, including all those that you may have had issues with because of the limit we just talked about, need to be turned in by Tuesday night. That's next to Tuesday night. Have to have time to grade them. Okay. If they were late from weeks back for whatever reason, let me know the reason. You're supposed to get prior approval, but if you turn them in close, it's going to be okay. And if you have, a reasonable story, then that may be okay as well. We'll have to deal with that on a case-by-case basis, okay? But no guarantee that I will have time to grade late homework, especially if you don't turn it in until Tuesday. After Tuesday, I will grade nothing that gets turned in, okay? And I think that's it as far as the stuff for that. The final project itself, okay? So remember that back in week, was it 9? Let me double check it. There's a week somewhere. I will find it eventually. Let's see. There's a forum. Oh, there it is. Week 9. Yes. The project discussion forum. So as part of the final project, you have to put what your topic is. And you really should have that by, let's say, Wednesday of this week, just so everybody has a chance to look at it. Okay, looking at it right now, looks like there are not a whole bunch of people there. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So about half the class. So the rest of you need to get something out there by Wednesday. That's part of your final assignment, okay? And I'm going through the Moodle side. I'm not sharing it because it doesn't really matter at this point, I don't think. But make sure you have that. And then for this week, the reading is chapter 14. Again, you normally should read the chapter before the video, but I know a lot of you probably don't do that. We're not covering all of it as usual, and I'll go through in a minute and tell you what to cover and what not to cover, okay? The homework there that's assigned, already it was assigned last week, will be due on Sunday night as normal. Okay, so a week from yesterday, basically. It's Monday right now, okay? And again, office hours this week on Tuesdays and Thursdays at 7, okay? Been getting reasonable attendance there. I don't think that the questions, the last couple of chapters have not been super difficult, and the homework hasn't been super difficult. I don't think so. There was not a whole lot of questions, and if you don't have questions, that's okay. You don't have to come to office hours just because. I will record them anyway. But if you do have questions, that would be a good place to start. Okay. And again, watch last Thursday's video, which is going to be what I expect to be on the final, or what the final is going to cover. And that certainly would be something to think about if you have questions, not just on 14 on strings, but on stuff in general. Okay. So let's talk about chapter 14. I'm going to go ahead and share the iPad. Okay, so we can kind of work through some of this, and then we may go to Eclipse as well. Okay, so again, this is chapter 14. Strings. Okay. And I guess the first difference, some of this we've kind of ran into before, but in a kind of an informal way. Okay, there's a difference between characters and strings. Okay, so a character is in single quotes. Okay, and it's a letter, a number. It could be like a new line character. That's a character. It could be lots of things. Okay, and these characters, it's going to be a value we're representing as a single character in single quotes. Okay, and what this really represents is an integer value of that character in the Unicode character set. It's actually the ASCII subgroup of that. ASCII was the longtime American symbolic standard, but now the world's more complicated. So Unicode covers a lot more codes. Okay, so every letter, every character, every punctuation, every new line character, all those have a numerical value. Every foreign character of most languages of the world also have a Unicode value. Okay, so what the character stores is really an integer value, which is weird to think about, that it's an integer, but it refers to a character. So if you say print out number 1285, that's probably not a real thing, but if that were the letter A, then that's what we would print out. Okay, so that's characters that we're talking about. Okay, so when we would call something like this a character literal. So a string then is a sequence of characters that we treat as a single unit. Okay, so a string literal would be something like hello. Let me spell it or write it correctly. Okay, that's a string literal. Okay, now I know in Python you could use single quotes, double quotes, didn't matter. In Java, as in C, it does matter. Single quotes means a character, double quotes means a string. You can have a string of one, so I can have a character string of Z, or I could have a character literal of Z, or a string literal of Z. Okay, and these are not the same thing. Okay, so a character, so the character literal, which we're using the char data type, is what we call a primitive data type. Okay, and Java is the only language I know that makes a big deal of this. But remember, in Java, everything is a class except primitive data types. Okay, so we've used a lot of primitive data types in here because it just turns out to be pretty handy. So ints, Boolean, float, all those are also these primitive data types. Okay, but string is not. Okay, so string is not. String is a class. String is an object. Okay, and that will make some difference in how we deal with things. Okay, so I could say something, for example, like I could say character C is equal to, I have to use single quotes, Z, that would be fine, okay? But I would want to do something for strings like string color is equal to double quotes blue, okay? And that's a string reference. It's a reference to a string object. Chars are not objects. Ints are not objects. They're just primitive half objects maybe, but a string is a full object, okay? So again, it's not a primitive data type, which does have some ramifications, okay? Which means we can talk about the string class. And the string class has a bunch of constructors, okay? The book lists just a couple. Okay, so we can say something like string x is equal to new string, just like that, okay? And that's just going to give us an empty string, okay? Instead, we could put another string inside of here. We could say string s, where s is a string that we've already defined, okay? Remember, we talked before about character arrays. It's going to be something like that, okay? So we could do inside of this, the string constructor would take a character array as well, okay? Or if you wanted to get just part of a character array, you could give it the string constructor with the character array followed by some offset, the place to start. So let's say 2 in our case, and then how many to do. So we could do 1, whatever. So that's where do you start? So that's the offset. That's there. And then that's the count of how many to get. Okay. And that's really the major constructors. You can do construct out of a lot of things, but that's the ones that we'll talk about. Okay. Then the book mentions some other methods that are pretty useful. We know that every object has a length parameter. So if we have s as a string, we can say s.length will return the length of the string. Okay. We can do a character at, which takes some integer. And that's going to return, again, a character. So it's a single quote thing that's at that position. Okay, so if I have my string s is equal to hello, then I could say, if I wanted to print out, but it doesn't matter, s dot character at 0 would refer to an h. Okay, that would be double quotes there. Okay, so it's going to get that character at. Okay. If you want to take a string and move it to a character array, you would use the get chars. Okay, so an s.getChars would give us, in this case, the h, the e, and so forth. Okay. As far as comparing strings, we normally compare with the equality, and that's good for primitives. And that works sometimes with strings, but sometimes not. Okay, so kind of a safer way. If we have string s1 is equal to a, double quotes, and string s2 is equal to a as well, okay, I could say something like if s1 dot equals s2, okay? And that's going to work in all cases. The double equal sign sometimes will work, sometimes it won't work. It depends on how the string is declared, okay? So the equals just ends up being a little more straightforward, or a little more, you can use it more often. Another big one there is the equals ignore case. Okay, that would allow that to be true. The equals ignore case, and there's no space between ignore and case. Looks like there is. Okay. So in this case, you don't care, capitals or not. Of course, you've got a 2 upper and 2 lower. You can always convert them. Sometimes you do care. If you care, then don't use ignore case, equals ignore case. But if you don't care, you could do that. Okay. There's also a compare to function. The compare to function is going to return a 0 if they're equal. Okay. It's going to return a negative if the one on the left is less than the one on the right, and then a positive number of some sort if it's on the other side. Okay. And that with strings, we can always rank them. Okay. So an A is smaller than a Z typically. What we're really doing, we're turning them to characters. Those characters appear in the Unicode, the ASCII portion of the Unicode code table. So we're looking at that number, comparing those numbers. Okay, so it's going to fall into alphabetical order, but case is going to mess things up. Okay, I think, but I'm not sure, that the capital letters come before the small letters. And I can look real quick. It's in Appendix B in the back of the book. So I recall the appendices might be a little hard to find. So maybe it'll take me a second here. Yeah, if I go straight to E. Okay, so there's A. And there's D, so B must be in there somewhere. Even though it's a big book, the pages seem pretty small. Yeah, so yeah, the ASCII character set starts with capital A is a 65, and a little a is a 97. Okay, so a capital A is smaller than a big A in that world. But you can always turn it into the same case using the 2 upper or 2 lower if you need to. Okay, that's something that you can do sometimes as well. In addition, there's a region match where you can see if part of a string is equal to the other string somewhere in the middle. There's a starts with and ends with, which compare the beginning and the ending of a string, and those can be pretty useful. Okay, if you're searching in a string, so searching for a substring inside of a string, you can do an index of, which returns the position of the first occurrence of the search string. Okay, and if it doesn't appear, I think it returns a -1. There's also a last index of, okay, it's capital I, which will return the last occurrence of that. Okay. There's a substring, which allows you to take, you've got a whole big string, you can return some sub portion of that with the substring function. Okay, either from a point to the end, or you can give it 2 parameters for the beginning and then how long to go. Okay, there's the concatenation function. Remember that if we have 2 strings, we can say S1 plus S2. The concat would be something like S1 dot concat S2, which it does the same thing, but sometimes it may be a cleaner presentation. Okay. We have the replace, where we can replace one character with another character within a string. Okay. Again, there's the 2 uppercase and the 2 lowercase, which allow us to, so if we would say S is equal to string S is equal to blue, like we did before, and if we were to say to print, so system dot out dot print line S dot to uppercase, it would print blue like that. Okay. The book talks about the string builder class. Okay. And we're not really going to mess with that too much. Just let me say, if you're familiar with other languages. Strings typically are what we would call immutable, which means we can't change the internal content of them. We can create a whole new string, but we can't mess with the internals of a string, okay, unless we change the whole thing. The string builder kind of gets away with that. So that's a mutable string array, okay? So don't worry about it for this class, but if you want to look at it, you're certainly able to do that, okay? Something else to know about, but we're not going to really mess with, is going to be these type wrapper classes. Make it look clear, wrapper classes. Okay, these are going to be things like integer, okay, things like double, things like float, okay, and these are class representations of the primitive data types, okay. And they have some different features. You can convert things from integers from an int into an integer and things like that. Again, if you do a whole bunch with Java, that's an important thing. We're not going to be doing enough to mess with that, but just wanted you to know that it was out there. Okay. Kind of the last thing that we're going to do, which both of the homework problems talk about, because it's kind of a big deal. It's something important that Java does that you may want to use a lot, and that's tokenizing strings. Okay, so in this sense, the tokens are going to be the individual words or punctuation marks or whatever that we find inside of a string that people would enter. Okay, and we use the split method with some delimiter to get to this. Okay, so we could do something like this. If we say string s is equal to 1, 2, 3. Okay. Then in order to get this back out, okay, we could use the split function. Okay. And what split is going to do, split is going to return an array, a string array. Okay. So I could say something like my new string array, call it words, is equal to s.split. And it takes, in this case, a space. So there's a blank space in there. Okay. When I do that, then words would be equal to 1, 2, 3. Okay. So if I wanted to print or do whatever with words sub 0, it would be equal to 1. Okay, and so forth. Okay. So that's the idea there. Okay, and I've lost everybody. I don't know where I'm at. Am I there? Okay, I lost the share entirely. So let me share that again if I need it. Maybe I don't need it. Okay. In fact, what I want to do next is go to this regular expressions examples. Okay. So with the regular expressions, you have a couple of things going on. Okay. For whatever reason, it popped up my computer screen on my iPad, which is not what I wanted. Okay. So when we're looking at this, let me make sure I'm sharing the right thing. It's my last video, of course, so it's got to be weird about sharing stuff. Okay, so let's go to Eclipse here. Okay, so here's an example of how we could use these regular expressions. Okay, and again, these are common among not just programming languages. We use it in mathematics and all kinds of things, but it mostly comes about through programming languages. And it's the idea that we're going to use these pretty arcane, weird little symbols in order to determine if something matches or not. Okay, so in this case, what I've done here, and I guess just to review the basics, whenever we have curly brackets, it's going to represent one character. Okay, and then I can put whatever my search conditions in there. So if I put like A-F, okay, this is going to be true if we have an A, a B, all the way to an F. Okay, has to be one character and one character only, and it has to be between A and F, small a and F. Okay, we more likely or more often see an AZ, which is going to get any single character between A and Z. Okay, so what I've done up here in this one, I've just got here if S dot matches one letter, so one character here, A to Z, and then another A to Z. Okay, so in this case, high should work, right? It's got two characters. Okay, if I add another letter there, it no longer works. Okay, in fact, I can, just to make sure it's a better test if we know that it's not just my program failing. Okay, if I run this, okay, then we have failure. Okay, and at regular expressions, I don't do them enough to be like super fluent with them. I kind of have the idea and I can look them up, but I think it's a smart idea if you're going to test a regular expression to maybe pull it out into a little program like this where you're just testing it to make sure you get the string right. Okay, that can be useful. Okay, so you can use regular expressions in your split as well. You can use them a bunch of places, but the matches is where you use them more. Okay, and we can use this for validation. Okay, so if we wanted, for example, to have it either uppercase or lowercase, we would have to put it in the same box here. Okay, so this is saying I want two characters. There are two sets of square brackets. Okay, they can be either uppercase or lowercase, and it's fine. Okay, so again, that should give me a success, and it does. If I switch that to an uppercase, it still gives me a success. Okay, and again, if I hadn't have done that, it would not be a success. That's a failure. Okay. Note also, if I would have done this, this would also be a failure. So for that to be true, it would have to be a lowercase letter, an uppercase letter, and then anything. So that would work for that. Okay. So make sure that you have it straight what you're trying to do. Okay. You can also put in some other modifiers here. Okay, so if I just wanted to say, so let's say I want the first letter, like on a first name, I want the first letter to be a capital letter. Okay, it's got to be a capital letter for the first character of the first name. Okay, I want it to then be followed by any number of letters here. Let's say I want it to be one or more. Okay, I could put a plus sign there. Okay, and then what I have now would not work. Okay, but high should work. Okay, that should not work, right? Because there's not any. That's a failure. But I could put, that would not, well, that would work. That would not work. Okay, because I have that capital letter. That should work. Yeah. Okay, so again, what this is saying is one uppercase letter between A and Z, followed by one or more of those. Okay. If you want it to be 0 or more of those, you would put in the star. Okay. This would allow that to be correct. Okay. Because that's saying 0 or more of these. Okay. And there's also a question mark if you want 0 or 1, but no more than that. Okay. So if I would put this in there, okay, this would be okay. That would be okay. that would not be okay. Okay. So again, you can fine tune what you want. I think some of you got confused the one in the book because it was doing the last name. Okay, so for building a last name, we're going to start with one capital letter like we have here. That's fine. Okay. And then if we're dealing all with straightforward names, then this is going to be okay here as well. Back to the probably 0 or more. I guess somebody could have a single letter last name. Okay. If you didn't think that was ever going to happen, you could put the plus there. Okay. But I have a friend, Wendell is his name. His last name's O'Brien. I always use him because he is a good test. Because if you do that, that's not right? That's not going to work. Okay. So I have to put another possible character in here. The character I want to put is that dash. Okay, or the asterisk. Okay. And I want there to be 0 or 1. Okay, because I can't imagine you'd need 2. Okay. So if I do that, still doesn't like it. I don't know why it doesn't like that. Do I have to have that inside of quotes? The book uses that example. I may have to find it. Okay, let me see if I can find it here. Okay, so let's see what it does. It does something a little bit different than I did. Okay, so it said for the last name, okay, it's going to be, oh, I guess it could, the dash wouldn't have to be right at the beginning. Okay, so it's doing, there's also an issue. A lot of, think of a lot of Arabic names are like Al this or whatever, which with a small a, or even Hispanic De La something. I know a woman whose name's De La Rocha. Those are small letters. So we're going to say small letters or big letters. Okay. And we're going to say that they're going to be the plus sign here. Okay. So the plus sign, again, is going to allow us to have one or more of those. Okay. Okay. And then it's putting, okay, oh, one or more. So it's putting parentheses around all of this. All the way. Oh, let's type it again. Make sure we get it correct. Okay, so we've got the little a to z, big A to z is our first character, plus, I'll get rid of everything here. Okay. We're going to take open parentheses, bracket, whether it's an asterisk or whether it's a dash. Some people have hyphenated last names. Okay, so that's where the hyphenated last names come in. Okay, then we're going to have again our A to Z, big A to Z. Going to have one or more of those. We're assuming no one thing names. Okay. And then we're assuming they're going to be 0 or more of these. Okay. To close our quote, that's what I wasn't doing before. That may have been the problem before in general. Still unhappy about something. Okay, let me see. I've got my first thing. So matches, da, 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 da. That ends plus parentheses bracket that, and that, AZ, plus, yeah, I know what it doesn't like. Oh, I'm missing one of those. There we go. Does that work? That works. Okay. So yeah, what this thing again is that we're going to have the 0 or, sorry, 1 or more character to start us off with, lowercase or uppercase. Okay. That's what this thing does. Okay. So 1 or more of these. Okay. And then we're going to have 0 or more of these, okay, which is going to be either the dash, the asterisk, or lower or uppercase letters. Okay, that's what that's going to do for us. Okay. It's also possible, if you wanted, you could have something like, if you want for there only to be 5-letter characters, you could specifically specify. You could specify exactly that you want like 5 of those. One more of those. And we're good as well. Okay. Again, one more would not work. Okay. So that's the basics of regular expressions. Okay. And again, they're not going to be on the final exam. They're not in the homework, so you can just ignore them if you like. But it's one of those things that there's always in every class the material that you really have to know to say you've taken the class. Then there's more supplemental material. Okay. So this was supplemental material that you should look through and for your own knowledge be familiar with, but it's not going to be, you're not going to be tested. You're not going to see it again in this class. Okay. You're probably not going to see it going forward, I wouldn't think, in either data structures or in algorithms. I mean, I guess you could, but I don't believe that you will. Okay. Okay, so that's it. I mean, chapter 14 is pretty straightforward. The two problems are both a little tricky. So the first problem asks you to take a telephone number that has the area code in parentheses, then a space, and then the first part, or the exchange, I would call that, dash the last part of the number. Okay. And it wants you to separate all those into separate string components. Okay. So it's definitely a job for the string split. Okay. But you're going to have to do it more than once because you have two different delimiters. So in the first time, when you want to separate out the area code, there's a space delimiter there. Okay. So when the first thing that you do, let me do this visually. That would make more sense, wouldn't it? Because I think these problems are quick, they're short. I did them in a few minutes with not very many lines of code, but sometimes those can be tricky. And I want to make sure that we're on the right path on these. Okay. Okay. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 as your number. Okay. Your goal is going to be to have the area code as one string. I'm going to call it the exchange, which is the 3 digits, as something, and then the number if you want. These are all strings. Okay. So right now, all of this is one big string. Okay. So your first split, which is going to change it to a new variable name, okay, is going to be delimiting on the blank space like we did before. Okay. So when you do that, okay, whatever you call it, this will be position 0. All of this will be position 1. Okay. So you can then set that to be equal to, I used n in my example, n0. Okay. And that will be equal to the 1, 2, 3. So you've got that part. Okay. But you're then going to have to split this again. Split it again this time on the dash. That'll split that into a 0 into a 1. Then you can just set the exchange to whatever you call that, the 0 part, and that will be the 1 part. Okay. And that's the idea behind that one. And then once you've done that, you'll be able to put it all back together. Okay. What the other problem, the last problem, the last homework of the whole class, does basically, if you have a phrase, I use something like 1, 2, 3, 4. Okay. That's what the user inputs. So that's our string. Okay. They want you to print it out in reverse. Okay. So when you do something like string words is equal to s.split. In this case, we're splitting on a blank space, and there's a space between those double quotes. Okay. You now have words. It's going to be equal to 1, 2, 3, and 4. Okay, and position-wise, this is words sub 0, words sub 1, words sub 2, and words sub 3. Okay, so all you have to do now is loop. So in this case, we're going to loop from 3 to 0. Okay, and 3 happens to be words dot length minus 1. Okay, so we're doing that backwards loop and doing a counter minus minus at the end to go back down and then to print those words out. That's all we're doing. Or if it wants you to, I forget what the problem says, if it wants you to make a new string that's just reversed, then you're just going to concatenate. So if you knew how many you were going to have, I could just say that reverse, assuming that's a string already, would be equal to words 3 plus, need a space, plus words, I can't write and think at the same time, 2 plus all the way down to word 0. Okay, but you want to do it in a loop. But that's the idea. That's how you reverse them. Okay. Okay, so hopefully that will help on the homework. Okay, again, I don't find it to be particularly daunting homework, but a little bit tricky. You have to, again, you're just worrying about we're split mostly is what you're worried about. Okay. Okay, so that's all we've got to worry about for right now. Okay. So this is Monday. This is going up. We'll have class office hours tomorrow at 7. It's Tuesday. And Thursday at 7 as well. Oh, Thursday's a problem. Won't be Thursday at 7. Let's make it Friday at 7 this week. I'm traveling back to Kentucky. My dad's doing fine. I just wanted to go in and check on him. So yeah, he's doing perfectly fine from his procedure, but I just wanted to come in and check on him. So I will be traveling back to Kentucky. So we'll do office hours again from Kentucky on Friday of this week. Okay. So I'm going to go change that on Moodle right now. Okay. As always, if you have any questions before then or whatever, make sure you let me know, and I will look at the forum as well. And don't forget to go into the forum on week 9 about the project, put in what your project's going to be to give me a chance to provide some feedback. Okay. Okie dokie, that's it for this week. Talk to you guys on Tuesday.